Okay, let's determine an equation of the line with a slope of -1/2 passing through the points 2 and -8. Alright, so if we're looking at the equation of a line, we're basically looking at slope-intercept form. We said was y is equal to mx plus b. Okay, and in this case, m was the slope, and b is the y-intercept, also known as where the graph hits the y-axis and x is 0. And in this case, we know that the slope here is -1/2 x plus b, and we know that it passes through the point 2 and -8, right? So we know that if the point 2 and -8 exists on our line, then we can just substitute that point into the equation. Any point that lies on a line will satisfy the equation of the line. This is true for any point that lies on any type of function or graph, right? That it will satisfy the equation of that function or graph, right? So if I substitute this point in, you can see that this is the y value is -8, and the x value here is 2, and if I plug this in, you get -8 is equal to -1/2 times 2 plus b, and then this cancels out, and -8 is equal to -1 plus b. Move the -1 to the other side. B here is -8 plus 1, which is basically -7. Okay, so if b is -7, that's my y-intercept. The equation of my line here is y is equal to -1/2 x minus 7. Okay, that's it. Alright, let's take a look at graphing linear equations. And we're going to be graphing these linear equations in the slope-intercept form. Alright, so let's take a look at the first linear equation. It's y is equal to -2/3 x minus 2. Right? So if I'm taking a look at this guy, we can see that the slope here is -2/3, and slope basically refers to rise over run. So rise is the change in y values, the run is the change in the x values, right? So this is telling us that our points are going 2 down and 3 to the right relative to each other, right? And I'll show you guys that when I plot this on the graph. The y-intercept here is -2, so the coordinate of the y-intercept is 0, -2, okay, because we know that the y-intercept is where x is 0. And the first thing I want to do here is plot the y-intercept, so 0, -2. And then I'm going to use the rise over run method. So you're going 2 down, right, because you have the negative on the numerator, and it's just easier to put the negative. If you have a negative on the fraction, put it on the numerator, and you can just kind of look at that as negative the rise if you want, or you're going certain units down. Okay, so it's 2 units down, and then you go 3 units to the right because you have a positive 3. So you go 1, 2, and then 3 to the right. So I'm just going to plot the point there. And I want to get another point on the left side of this. So if I'm going backwards, I'm going 3 units to the left, 2 units up, right? And you can see that here is our line segment. If I just plot the points, you guys are going to do this with a ruler, right? It'll look a lot more nicer, but I just don't have a ruler on me. But this is what the line segment looks like, right? Now, looking at the second question, I'm just going to change colors here. Okay. So looking at the second question, y is equal to 3x plus 1/4. Okay, the slope here is 3, right? So in terms of rise over run, it's positive 3 up and positive 1 to the right. Okay, and the y-intercept here is 1/4, and you can also write this as 0.25 because it's a terminating fraction, right? And therefore it is a rational number. So the point here is 0 and 1/4. So I'm going to plot the y-intercept first. So 0 and 1/4 is approximately, let's say it's here. Okay, so it's 0.25. Now this is a little bit more trickier because we have a decimal involved. And we can see that the slope here is 1 to the right and then 3 up. So we're going to go 1 to the right and 3 up. So if I go 3 up, the idea here is that I'm going to add 3 to 0.25. So it's going to actually end up in 3.25. Okay, and if I do that backwards, right? So if I go backwards and I find the point there, right? You have 0.25 and you're subtracting by 3, right? So you get like -2.75. So let's say it's like here, and you're moving to the left 1. Okay, so let's say it's here. So this is what the point looks like. So you can see that with decimals, it's going to be a little bit more trickier, right? You'd have to actually ballpark these sketches, right? And yeah, that's how you basically graph linear equations using the slope-intercept form. Alright, let's take a look at graphing this equation in standard form. All right, so I'm going to change the linear equation from standard form into y is equal to mx plus b. So that's basically the slope-intercept form. So the way I do that, I'm going to basically isolate for my y value. So I'm going to move my other two terms to the right side of the equation. And you get 6y is equal to 3x minus 8. Now I don't want to solve for 6y, I want to solve for y. So I'm going to divide by 6. Whatever I do to one side, I'm going to do, and I'm going to repeat that to the other side. All right, so now you get y is equal to 3 over 6 is 1/2, so 1/2 x minus 8 over 6. If you kind of like reduce this by dividing by 2, you get minus 4 over 3. All right, now you can notice here that this is going to be, there's going to be some kind of issue if we use the slope-intercept form of plotting. All right. And that's kind of what I showed you guys in the previous video. Now, the reason for this is because we can see that the y-intercept, this is an irrational number, right? Because 4 over 3 is like 1.333, and it's just going to keep going, right? So it's going to be really hard for us to ballpark this. So I'm going to look at another way to kind of graph this, and we're just creating a sketch, really, right? Now, the way I'm going to do this is through the intercept method of plotting. So how the intercept method of plotting works. Okay, so the intercept method, we're actually going to solve for the y and the x-intercept, and then what we're going to do here is then plot those points and then connect the 2 points. All right, so I'm going to start with my x-intercept. Now we know that the x-intercept occurs when y is equal to 0, so I'm just going to model that in my equation. So I'm going to let y equal 0, and in this case you get 6 times 0 minus 3x plus 8 is equal to 0, and basically this kind of cancels out, so you get negative 3x plus 8 is equal to 0, so negative 3x is equal to negative 8, right? If I just divide this by negative 3, cancels out, x is equal to 8 over 3, okay? So 8 over 3, you guys can punch this out in your calculator. It's about like it just keeps going, 666, right? Now, this is an irrational number as well, but once again, I'm just trying to ballpark this. So we know that's somewhere a little past the midpoint of 2 and 3, all right? So that's your x-intercept, right? So I can place that point there. This is 8 over 3 and 0. And for the y-intercept, what I'm going to do here is I'm going to let x equal 0. If I let x equal 0, you're going to get 6y minus 3 times 0 plus 8 is equal to 0. 6y plus 8 is equal to 0. I'm going to move the 8 to the other side. 6y is equal to negative 8. Y here is equal to negative 8 over 6. And if I divide this by 2, you basically get negative 4 over 3. So the point here is 0 and negative 4 over 3. Okay? So once again, this is also an irrational number, right? Negative 4 over 3 is equivalent to negative 1.333, and it just kind of keeps going. Once again, I just needed to ballpark the value. So let's say it's like somewhere here, right? It's a little bit below the midpoint part. And now what I want to do is with the intercepts, I'm going to connect the 2 intercepts. When I connect the 2 intercepts, you can actually generate a line, right? So let me just do that here. And in this case, this is what the line looks like. And it's not completely accurate, but it's a really good approximation. It's a lot better of an approximation than using the slope-intercept form. Okay, let's find the equation of line segment CD with endpoint C, which is 3 and negative 4, and D, which is negative 1 and 6 in standard form. First off, we looked at the equation of a line in slope-intercept form, which looks like y is equal to mx plus b, right? And standard form is just another form of the line. It's just written as ax plus by plus c is equal to 0. Right, so technically it is your slope-intercept form, but you move all your terms to one side and you let the other side equal 0. Right? So what we could do is actually solve for our the equation of our line in slope-intercept form and then change it to y-intercept form. To standard form. All right, so let's look at the equation of our line in slope-intercept form. So we have 2 points. We have C and D, right? I'm just going to sketch this guy out just so you guys have an idea of what it looks like. Point C is found in, well, we know that this has a positive x-axis and a negative y value, right? So it should be found in the 4th quadrant, so it should be found somewhere here. So I'm just going to put that here. Okay, let's call this point C, and this is 3 and negative 4. And point D here is negative 1 and 6, right? So you can also notice here that this guy, negative x, positive y, I would probably find in the 2nd quadrant. I'm going to put it here, right? and this is point D. And once again, guys, this is like a scale, right? And what I want to do here is, this is my line segment, right? And these are the two endpoints of my line segment. And if I look at this, I want to figure out my slope, right? So I'm looking for my slope. Slope is y2 minus y1 over x2 minus x1. You can make point 1 any of these 2 points. It doesn't matter what the order is, right? So I'm going to call C here point 2. I'm going to call D here point 1, right? So y2 here is -4, minus y1 here is 6, x2 here is 3, minus x1 here is -1. So make sure you guys pay attention to the integers, and you get -4 minus 6 and 3 plus 1, and you basically get -10 over 4. Okay, and this is approximately like -2.5, right? Or you guys can reduce this a little bit, right? And you can get this as -5 over 2 if you want. Okay, so the slope here is -5 over 2, and now we have y is equal to -5 over 2 x plus b. You want to solve for b, I'm going to substitute a point. So I'm going to substitute the point D, -1 and 6, right? Because we know that any point that lies on a line will satisfy the equation of the line. So I'm going to substitute this point into this equation. When I do that, I get 6 is equal to -5 over 2, -1 plus b, and 6 is equal to 5 over 2. The negatives will just kind of cancel out, plus b, and you have 6 over 1 is equal to 5 over 2 plus b. I'm going to just change this, make it a common denominator, so you get 12 over 2. I'm going to move the 5 over 2 to this side, isolate for b, so you get -5 over 2 is equal to b, and b here is equal to 7 over 2. So the equation here looks like y is equal to -5 over 2 x plus 7 over 2. Now this is the slope-intercept form. We're not done yet. We want to find this in standard form. If we want to find this in standard form, let's move all the terms to the left side. I'm going to make the right side 0. So y plus 5 over 2 x minus 7 over 2 is equal to 0. Now, what standard form prefers is we want whole numbers, right? So we want whole number coefficients. So you can see that all of these guys have a denominator of 2, right? This guy has a denominator of 1. If I can multiply everything by 2, I can just cancel out the denominators, right? Now, to do that, I'm going to multiply 2 to this side. Whenever I do to one side, if I repeat that to the other side, it just keeps it constant, right? So I'm just going to move this here. And when you're multiplying, you want to kind of distribute the 2 to all of these terms. So you get 2y plus 2 times 5 over 2. The 2's and the 2's will cancel out, right? So you get 5x, 2 times minus 7 over 2. The 2 and the 2 will cancel out. You get -7 is equal to 0. So this is what your equation looks like in standard form. Determine the slope and y-intercept of the linear equation 5x plus 3y minus 12 is equal to 0. Now if we look at this linear equation, this is actually in the form of ax plus by plus c is equal to 0. And we said that earlier, this was called standard form. Okay, so in standard form, we can notice here that all the terms are to the left side and the right side is 0. What we want to do here to determine the slope and y-intercept really quickly, I'm going to transfer this or convert this into the slope-intercept form, y is equal to mx plus b. Okay, so to do that, first thing I want to do here, and I'm just going to rewrite our equation, the first thing I want to do here is isolate for y. Alright, so to isolate for y, I'm going to get 3y by itself first. So 3y, I'm going to move the other terms to the other side. So 3y is equal to -5x plus 12. Now you need to isolate for a y, or 1y, not 3y. So I'm going to divide this by 3, right? Now when I divide this by 3, to keep the entire equation the same, I'm going to do the same thing to the right side. So I'm going to divide all of these terms by 3. Now when you divide all of these terms by 3, you can rewrite that as -5 over 3x plus 12 over 3. So you have to divide each term individually by 3. So now y is equal to -5 over 3x plus 12 over 3 is basically 4, right? And this is what your equation looks like. And because now it looks like the slope-intercept form, you can see that the slope here is -5 over 3. And the y-intercept here is 4, right? So it's 0 and 4. And So let's look at sketching more linear equations. And in this case, I'm going to use the intercept method to sketch this equation that's already found in standard form. Right, so we don't actually need a grid paper for this, right? We can sketch a graph by just plotting the key points. Now, if I'm using the intercept method, I need to find the two intercepts, so that includes my x-intercept and my y-intercept in 2 dimensions. So if I'm looking at my x-intercept, I'm going to let y equals 0, right? Because the x-intercept is where the graph hits the x-axis, and we know that the x-axis is when y is 0, right? So if I let y equal 0, then you get 5x plus 2 times 0 minus 10 is equal to 0, and you get 5x minus 10 is equal to 0. I'm going to move the negative 10 to the other side. You get 5x is equal to positive 10, right? I'm going to divide this by 5. Whatever I do to this side, I have to repeat to the other side. And in this case, x is equal to 2. So your x-intercept here is 2 and 0, right? I'm going to do the same thing, but this time I'm going to find the y-intercept. And so when I find the y-intercept, I have to let x equal 0. That's when the graph hits the y-axis. We know that the y-axis is where x is 0. And in this case, if I let x equal 0, I get 5 times 0 plus 2y minus 10 is equal to 0. So 2y minus 10 is equal to 0. If I move the 10 to the other side, 2y is equal to 10. I want to solve for y, not 2y, so I'm going to divide by 2. Whatever I do to this side, I'm repeating to this side. And y is equal to 5. All right, so your y-intercept here is 0 and 5. So now you have your x-intercept and you have your y-intercept. What you want to do is plot this, right? So your x-intercept here is 2 and 0. Your y-intercept here is 0 and 5, right? And once again, guys, you can create a scale if you want, but once again, we just want to create a sketch, right? We don't really need to be really exact with this. We just need the key points, and that's basically what your graph is going to look like. All right, let's sketch the graph y is equal to 1/2 x minus 4 over 3 using the intercept method, right? So this is basically our slope-intercept method, or slope-intercept form of a linear equation, right? And because we know the b value, right, in this case b value here is negative 4 over 3, that b value represents our y-intercept, right? So our y-intercept here is already given, so we don't really have to calculate it. It's basically 0 and negative 4 over 3, okay? So the only thing we really have to do here is find the x-intercept. So if I'm finding the x-intercept, we know that this is where the graph hits the x-axis and y is equal to 0. So I'm going to model that by letting y equals 0. So if I let y equals 0, 0 is equal to 1/2 x minus 4 over 3, right? And I want to solve for my x-intercept. So I want to move the negative 4 over 3 to this side, to the other side, and you get 1/2 x is equal to positive 4 over 3. And I want to solve for x, so I need to get rid of the 1/2. So the way I can get rid of the 1/2 is multiply by 2, right? And whatever I do to one side, I'm going to repeat that to the other side. So 2 is basically 2 over 1. Cancels out, you get 1x. X is equal to 8 over 3. Now 8 over 3 is approximately like 2.66, and it just kind of keeps going, right? We just want an approximation for this. It's likewise for negative 4 over 3. This is basically like negative 1.333, and just kind of keeps going from there. Once again, this is just a sketch, so we don't really have to be exact, right? We're just kind of ballparking the image. So I'm just going to kind of create like a set of gradients. Negative 1, negative 2, negative 3. You guys don't have to draw this to scale, right? Once again, it is a sketch. We just need the key points. Okay, so one of the first points that I'm going to look at here is the 0 and negative 4 over 3. So the negative 4 over 3 is going to be like negative 1.33. Let's say it's like right here, right? The other point here is the 8 over 3 and 0, because that's our x-intercept, right? And that's going to be like 2.67-ish. So that's going to be a little past the midpoint. And after we plot the intercepts, all we have to do is just connect the two, right? So if we connect the two, we basically get this, and that's basically our line. Let's consider a linear system. So a linear system is basically a system of two or more linear equations, okay? And we've taken a look at a few linear equations. We looked at them in slope-intercept form as well as standard form. And we can actually glean some relationships regarding linear systems, okay, or series of two or more linear equations. Now when we're looking at a linear system, linear equations can first of all be parallel or non-parallel. Now linear equations, equations of lines, right? Basically they'll describe a portion of that line. These lines can be parallel in the sense that they don't intersect, right? So these are two examples of parallel lines. Okay, so this is line 1 and this is line 2, and we can note here that these lines, if they are perfectly parallel, if you extend them infinitely, they're never going to meet. Okay, so you can imagine them as two rails of a railway track that just keep going on and on forever, right? Now, when two lines are actually parallel, we actually will notice that the slopes of the two lines, m1, which is the slope of line 1, and m2, which is the slope of line 2, will be equal. Okay, so this is something that you want to note. For any two lines that are parallel, the slopes of those two lines, two or more lines, are going to be the same. Okay, so parallel lines are going to have the same slope. Okay, so the easiest way we can analyze the slope is by looking at these lines in the slope-intercept form, which we've already previously discussed. Okay, and because these lines don't meet, you won't expect them to intersect at a point. So there will be no point of intersection. Okay, I'm going to abbreviate point of intersection as POI. Okay, and if we want to say that line 1 is parallel to line 2, an easy way to write this is we use this symbol here. This means parallel to. Okay, so we can just say that if the slope of line 1 is equal to the slope of line 2, then line 1 is parallel to line 2. Okay, so this is something that you kind of want to understand. Okay, so it's good to kind of understand this, these symbols, because we don't want to write all of this out. It just takes too much time, right? So it's good to kind of utilize some of these symbols to just kind of shorten our sentences. Now, if two lines are not parallel, that means that they will eventually meet at a single point, and that point being the point of intersection. The slopes will not be the same, right? So they will be non-parallel if the slope of line 1 is not equal to the slope of line 2. And we're just considering two lines. You can have more than two lines in this linear system, right? But once again, we're just going to kind of look at just two lines, just to make it a lot easier, right? So a linear system is going to encompass two or more linear equations. Okay, so that's literally what a system is. It has multiple equations. Now, if we're looking at the case where the lines are non-parallel, right, in case of the lines that are non-parallel, then the slopes won't be the same. Okay, so if the slopes won't be the same, then line 1 and line 2, and let's say that this is line 1, this is line 2, they'll eventually meet at a particular point. Okay, so this point that they meet at, this point here, this is called a point of intersection. Okay, and what is important to understand when you're kind of looking at these linear equations and these systems is that we noted earlier that a point that exists on a line will satisfy the equation of the line, right? Now, this point of intersection actually exists on both lines in this system. So as a result, this point of intersection, which is we're going to look at in two dimensions, x and y, it's going to actually satisfy both equations of line 1 and of line 2. So that's something that you want to understand. Okay, and we're going to look at this in more detail when we actually solve for the point of intersection, when we're actually investigating these linear systems algebraically, but for the time being, this is a really important point to understand. Okay, so if the slopes are not the same, right? If the slope of line 1 is not the same as line 2, then line 1 is not parallel to line 2. And when two lines are not parallel, this implies that they will meet at a single point. Okay? Now we can actually subdivide non-parallel lines based on how they intersect, right? Because we said that any line that is not parallel, for the most part, if you extend it indefinitely in two-dimensional space, they will eventually meet at a single point. Okay? Now, basically, the point of intersection can occur in two different fashions. At a 90-degree angle, which is basically a right angle, or a non-90-degree angle. Okay? Now, let's take a look at the case where the two lines actually intersect at a 90-degree angle, right? So this form of intersection means that the lines are basically going to be perpendicular to each other, right? So perpendicular means to intersect something at 90 degrees. And we use the symbol, this upside down T here, to state that two lines are perpendicular. Okay, so this means perpendicular to. Okay, now you might also hear the term orthogonal to. It's just another term for that, right? They're basically synonyms, right? So you can call it perpendicular orthogonal to, right? And basically, if two lines are intersecting at a 90-degree angle, which I'm just going to demonstrate like so, right? This is line 1, this is line 2, this is your point of intersection, right? And when they intersect, they create these 90-degree angles here, right? This means that line 1 is perpendicular to line 2. Now, the way we can actually notice this in terms of their slopes, if we compare the two linear equations in terms of their slopes, the slopes are negative reciprocals. Slopes are negative reciprocals. So what is a negative reciprocal? Well, if you had, if the slope of line 1 was 3 over 4, right? The negative reciprocal of 3 over 4 is, well, first of all, the reciprocal is when you flip the numerator and denominator, so you get 4 over 3, right? And the negative reciprocal means you've multiplied this by a negative value. So if the slope of line 2 is negative 4 over 3, then it is a negative reciprocal of the slope of line 1, right? So in this case, basically, line 1 would be perpendicular to line 2, right? So if line 1 is perpendicular to line 2, this will only occur if slope 1 is equal to negative 1 over slope 2. Okay, and this means this is basically the algebraic way of writing negative reciprocal. So you can think about it this way if you want to look at it algebraically, right? Or you can just remember that the two slopes have to be negative reciprocals to basically intersect at a 90-degree angle. Okay, now if the slopes are not the same, right, and being negative reciprocals, that just already implies that the slopes aren't the same. But if the slopes are not the same and they are not negative reciprocals, then we just intersect at any angle. So it's a non-90-degree angle. Okay, so that's what you want to understand. So we can just say here, if slope 1 is not equal to negative 1 over slope 2, right? So not negative reciprocals, and they basically intersect at any angle, right? So this is still true, that the slopes will be different. Okay, so this is just an idea or a general concept map of some of the relationships you would see in a linear system, but I think it would be more effective if we will do some questions next to just kind of demonstrate all of this material. All right, let's determine the relationship between the lines in the following linear system. And if we're trying to find the relationship of lines in a system, we should be first analyzing the slope. All right, so I'm going to look at the slope of all the lines. We can notice here that line 1 and line 3 are in slope-intercept form, also known as y is equal to mx plus b form, right? And m here is the slope, right? So the slope of line 1 here is given as positive 2, right? And you can write this as 2 over 1. And the slope of line 3 here is given as negative 1/2. Now, it's not too clear what the slope of line 2 is. So what I want to do here is, we can notice here that line 2 is found in standard form. I'm going to change it to y is equal to mx plus b form. And the way I do this, I'm just going to isolate for y by moving the other two terms to the other side, right? So you get 3y is equal to negative 4x plus 12. I don't want to solve for 3y, I want to solve for 1y, so I'm going to divide this by 3. Whatever I do to one side of the equation, I'm going to repeat that to the other side of the equation. You notice here that you get y is equal to negative 4 over 3 x plus 4, right? So you can see that the slope of line 2 here is negative 4 over 3. Now I'm going to compare the lines. So I'm going to start with line 1 and line 2, right? So you can see that slope of line 1 here is 2, and slope of line 2 here is negative 4 over 3. So the slope of line 1 does not equal the slope of line 2. This means that line 1 is not parallel to line 2. And when two lines are not parallel to each other, that means that they're basically going to intersect at a certain point, right? And that point is called the point of intersection. All right? So that's the idea. Now we have to also compare slope 2. Oh, before I do that, one thing that we should note is that, okay, these lines do intersect at a certain point, but we need to also look at the angle of intersection. So we can notice here that these two slopes, right, slope 1 and slope 2, these are not negative reciprocals of each other, so they basically intersect at any angle. Okay, so keep that in mind. Let's look at slope 2 and slope 3. So we can see that slope 2 here is negative 4 over 3, and slope 3 here is negative 1/2. They're not equal, right? So in this case, therefore, line 2 does not parallel to line 3. So it does intersect line 3 at some point, right? And in this case, because the two slopes are not negative reciprocals of each other, then they can intersect at any angle. Okay. The last pair that we have to compare is slope 1 and slope 3. So you can see that slope 1 here is 2, and slope 3 here is negative 1/2. You can see that they're both not equal, right? So therefore, line 1 is not parallel to line 3. That means line 1 will intersect line 3 at a single point. But we can also notice here that this angle of intersection is going to be a 90-degree angle. And we know this because these guys are negative reciprocals of each other, right? So if you flip the graph, if you flip the fraction and you put a negative, they're both going to be negative reciprocals. So this is going to intersect at a 90-degree angle, right? Or you can say that the lines are perpendicular to each other at the point of intersection. Alright, we want to determine the point of intersection for the linear system by graphing. So if I'm looking at finding the point of intersection by using the graphing method, first I'm going to create a sketch of the two lines within my system. So here we have line 1 and line 2. They both look like they're in standard form. So I'm going to start with line 1, and I'm going to use the intercept method to create a sketch of this line. Alright, so if I'm using the intercept method, I'm going to first find the X-intercept. So I'm going to do this by letting y equal 0. So you get 2x plus 0 is equal to negative 3. So you get 2x is equal to negative 3. I want to solve for x, so I'm going to divide this by 2. And whatever I do to one side, I'm going to repeat to the other side. So x is equal to negative 3 over 2. So we can see that our X-intercept is negative 3 over 2 and 0. Okay, so that's one of our X-intercepts for one of our lines. And I want to find now the Y-intercept for line 1. So I'm going to let x equal 0. And in this case, if we let x equal 0, we get 2 times 0 plus y is equal to negative 3. So we can notice here that y is negative 3. So we have 0 and negative 3 as our Y-intercept. So I'm just going to create like a general sketch here. Okay. So that's my graph, and then basically you can just like ballpark the points. Negative 3 over 2 is like negative 1.5, so it's like in the middle of negative 1 and negative 2, right? So this is negative 3 over 2 and 0. And we also have the Y-intercept, which is 0, negative 3, so it's going to look like that. And in this case, let's call this guy line 1, and I'm going to draw that blue, so it looks like that, really. Okay, so this is line 1. Okay, and that's what our line looks like. Now I'm going to do the same thing for line 2. I'm going to find the x and y intercept, and then we're going to plot it by using the intercept method. Alright, so If you guys aren't too comfortable with the intercept method, just go back and review some of my videos regarding sketching by using the intercept method. So I'm going to look at line 2, and line 2 you get 3x minus y is equal to 8, so I'm going to find the x-intercept first, right? So I'm going to let y equal 0, so you get 3x minus 0 is equal to 8, 3x is equal to 8, oops, and x here, if I divide this by 3, x is 8 over 3, so it's approximately 2.66. You can round that to 2.67. We're just trying to ballpark it. So the point here is 8 over 3 and 0. That's my x-intercept. Now I'm going to just move over here to find the y-intercept for this line 2. I'm going to let x equal 0. If I let x equal 0, you get 3 times 0 minus y is equal to 8. And you can see this cancels out. Negative y is equal to 8, so if I multiply this by negative 1 to get rid of the negative, y here is equal to negative 8, right? So you can see that the y-intercept is 0 and negative 8, so if I plot this, right, 0 and negative 8, okay, let's say that I didn't really incorporate that in my sketch. Let's say negative 8 is here or something, okay? And let's say that our x-intercept here is 8 over 3, so it's like 2.67. Guys, this isn't to scale, but I just want you guys to understand how to do it, right? Clearly I'm limited for space, and if I just kind of connect the points here, right, and hopefully you guys kind of use a ruler, I'm just kind of showing you how this works. You can see that there should be a point of intersection at this point. Now you can notice here that if I did do this on an actual Cartesian plane, right, if I did this on a proper Cartesian plane, you could actually kind of ballpark that point, right? This is your point of intersection. But this is one of the downsides of this method, is that it's very, it's an approximated method, right? There are more accurate ways, like the elimination substitution method, to solve for the point of intersection. All right, let's calculate the point of intersection for the following linear system via the substitution method. So here we have two lines in our system, right? We have line 1 and line 2. Before I kind of calculate for the point of intersection, I just want to verify that these two lines in fact do intersect, right? So slope of line 1 is equal to negative 3, because we're basically looking at it as y is equal to mx plus b, and m here is the slope. Okay, and the slope of line 2 here is 1/2. So you can notice here that slope of line 1 is not equal to slope of line 2. That means line 1 is not parallel to line 2, so they will intersect. And we can notice here that they should intersect at any angle, right? It's not specifically a 90-degree angle in this case. All right, so if we're looking at solving for the point of intersection, we're going to use the substitution method, and basically at the point of intersection, right, y1 should equal y2, right? Both equations or both lines should have the same point of intersection. They'll have the same x and y value, okay? So that's why I can equate the two y values, and if I equate the two y values, what I'm going to see here is that negative 3x minus 4 is equal to 1/2 x plus 2. Now I want to solve for that common x value, all right? So if I'm solving for that common x value, you can notice here that I have a half here. If you want to make your life easier and you don't want to work with fractions, I'm just going to multiply this side by 2, and whatever I do to one side, to keep the equation the same, I'm going to multiply the other side by 2. So basically what you get, if you distribute this, you get negative 6x minus 8 is equal to, if I distribute this, you get 2 times 1/2, which is 1, so x plus 4, right? And then I'm going to collect the like terms as so, then you get negative 6x minus x is equal to 4 plus 8, then you get negative 7x is equal to 12, and x, if I divide this by negative 7, right, I'm just going to make some space there, x is equal to negative 12 over 7, okay? So that's the x value. If you want to find the y value, then you can just resubstitute this into an equation. So I'm going to resubstitute this into equation 1, right? It doesn't matter what equation you substitute this back into, because they both have the same y value. So if I substitute this back into equation 1, you get y is equal to negative 3. Instead of x, I'm going to plug in negative 12 over 7. So you get negative 12 over 7 minus 4. So y here is equal to, if I multiply this, you get 36. Remember the negatives cancel out. 36 over 7 minus 4. And this is 4 over 1. If I'm subtracting fractions, make sure the denominators are the same, right? So you get y is equal to 36 minus 28 over 7, which is 8 over 7. Okay? So the point of intersection here is therefore negative 12 over 7 and 8 over 7. And that's how you use the substitution method. Alright, let's solve the linear system via the substitution method, right? So you can see that in this case the linear systems following the two lines are in standard form, right? So it's going to be a little bit more difficult. We know that at the point of intersection, right, y1 should equal y2, right? So you can actually think about this as y1, or the y value of line 1, and y2 as the y value of line 2 if you want, right? Now to do that, I'm going to basically isolate for y for one of the equations. So I'm going to do that for y1, alright? So y1 here, and if I have, this is what my equation looks like, let's call this guy equation 1. Right, this is what equation 1 looks like. I'm going to move the 2x to the other side, so y1 here is negative 3 minus 2x, right? Now if I want to find my point of intersection, I have to equate y1 with y2, so I'm going to substitute this segment into equation 2, which is for line 2. Okay, so if I plug that in, you get 3x minus wherever I see y2, right? Wherever I see y2, I'm going to plug in negative 3 minus 2x is equal to 8. Now, you have to notice here that when you're doing these substitutions that you do provide a bracket for them, right? So it's really important, especially because in some cases you'll have negatives and you have to actually distribute that out. So you get 3x, if I distribute the negative out, we get negative times negative, which is positive. So positive 3, negative times negative 2x, or negative 1 times negative 2x is positive 2x, is equal to 8. I'm going to collect the like terms, so the 3x and the 2x. You get 5x plus 3 is equal to 8. I'm going to move the 3 to the other side. 5x is equal to 5. I want to solve for x, so I'm going to divide by 5. And I'll repeat that to the other side. So x here is equal to 1, right? Now that I know that x is equal to 1, I need to find my y value, so I'm going to substitute this into equation 1 or 2, it doesn't matter. I'm going to substitute this into equation 1, so you get 2 times 1, wherever I see x I plug in 1, plus y is equal to negative 3, so 2 plus y is negative 3. Y is equal to, if I move the 2 to the other side, negative 3 minus 2, which is negative 5. Alright, so this tells us that our point of intersection here is 1 and negative 5. Alright, let's determine the point of intersection of the following linear system using the elimination method this time. So if I'm looking at the elimination method, the whole point of the elimination method is to isolate for a variable and eliminate the other variable. And how we can do this is by performing operations to each linear equation. So how I'm going to do that is I'm going to call this guy equation 1 and this guy equation 2. Equation 1, I'm going to put all the terms that include variables on one side of the equation and all the constants or the numbers on the other side of the equation. So I'm going to take the negative 2 over 3x, I'm going to move it to the left side, so you get y plus 2 over 3x is equal to negative 2, right? And for equation 2, I'm going to move the 2x to the other side, you get y minus 2x is equal to 6. And what I want to do here is I'm going to eliminate for a variable and isolate for another variable. Now, if you guys don't want to work with fractions, what you could do for equation 1 is I'm going to multiply the left side by 3 to cancel out the 2 over 3, right? So I'm going to multiply equation 1 by 3, and whatever you do to the left side, I have to do to the right side, right? So you get 3 times y plus 2 over 3x is equal to negative 2 times 3, and you basically, if you distribute this, you get 3y, 3 times 2 divided by 3, you can just kind of cancel the 3's out, you get like 2x, right, is equal to negative 6. So you can also work with this, right? So now equation 1, you get 3y plus 2x is equal to negative 6. Equation 2, you get y minus 2x is equal to 6. Just to make it easier, I'm going to isolate for y, and you don't have to isolate for y. You can isolate for x and eliminate for y. I'm going to isolate for y, eliminate x. And the reason I want to eliminate x is because if you notice here that if you look at the two x values, they're basically the same magnitude. They're just opposite in signs, right? So we can really eliminate a variable pretty quickly if we have the same magnitude. And that's the whole point of what I'm trying to do here. So because they have opposite signs, if I add these two equations, right, you can see that this would eventually cancel out. Now when you add equations, you have to add the left side independently from the right side, right? So if I add the left side of the equation, this cancels out. You get 3y plus y, that's 4y, and then you get negative 6 plus 6, which is 0. So think of the equal sign as just like a wall that separates the left side and the right side. Okay, so you get 4y is equal to 0, and if we want to solve for y, I'm just going to divide by 4. And you can notice here that y is equal to 0. Okay, so once we know what y is, we want to substitute back into the equation to solve for x. We know that at the point of intersection, both equations will have the same x and y value for the point, right? So that point will lie on both lines. Now if I have y is equal to 0, I'm going to substitute y is equal to 0. I'm going to use, you can use either or equation. I'll use equation 2, right? Y here is equal to, whoops, y is 0 in this case, sorry. 0 here is equal to 2x plus 6, right? You want to solve for x, I'm going to move the 6 to the other side. 2x is equal to negative 6. Right, if I want to solve for x, I'm going to divide this by 2. Whatever I do to one side, I have to repeat to the other side. X here is equal to negative 3. So collectively, the point here is negative 3 for x and 0 for y, and this is the point of intersection. Okay, and yeah, that is how you solve for it using elimination.